third prep. Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have a new lesson. The lesson is geometry. It's unit 5, lesson 2. The lesson is called the coordinates of the midpoint. In this lesson, we are going to learn how can we identify or find the coordinates of the midpoint and what is the meaning of the midpoint, and how can we use this midpoint to find the missing part and to complete the missing point in the quadrilateral, for example, rectangle, parallelogram, and so on, and by using the center of the circle. Okay, let's start the lesson. First, I need to introduce what is the meaning of the midpoint. The midpoint is a point that lies at the center of the line segment, or the point which make a balance in this line segment. We use this midpoint to find the coordinates of the midpoint. For example, if we have a map like this and we need to identify or to find the position lie at the middle of the way between two countries, then we divide the map into a graph, then finding the coordinates of the midpoint which represent the middle the way between two points or two countries. Okay, now I'm going to learn how can I find the coordinates of the line segment. Okay, I will divide the introduction into 3 parts. First, I'm going to teach you how can I find the coordinate of a horizontal line segment. Second, I'm going to introduce how can I find the coordinates of a vertical line segment. Finally, I'm going to teach you how can I find the coordinates of a line segment in general. Okay, by looking to this graph, if we have a point like this, point A is 1 and 1, and another point B is 5 and 1. By looking to the coordinates 1 and 1, this is x1 and y1, this is x2 and this is y2. Okay, by connect them like this, we find that the position of the midpoint here in this position like this. I will call it C. Okay, C here, by looking to C, C is opposite to 3 and opposite to 1, then coordinates of C is 3 and 1. Okay, now A is called x1, y1, B is called x2, y2. Okay, now there is a relation between, as I said, C in the midpoint here. Okay, there is a relation between x coordinate and y coordinate. Because the 3 points are horizontal, then all of them opposite to 1. Okay, so the y coordinate is stable, 1, 1 and 1 like this. But the x coordinates are different. Here x1 is 1, x2 is 5, and x of C is 3. There is by looking carefully to the 3 numbers, you find that 3 lie at middle the way between 1 and 5, or half the sum of 5 and 1. For example, 1 plus 5 equal 6. 6 divided by 2 equal 3. Then this is the rule. 3 or x of the midpoint equal half the sum of x1 and x2 like this. 1 plus 5 over 2 equal 3 like this. This is the rule of x coordinate, x1 plus x2 over 2. Okay, now there is only one rule for the x coordinate because the line segment is horizontal. Now let's study another type of line segment, which is the vertical one. For example, point B, as we said, 5 and 1, and another point D is 5 and 5, as you see. The midpoint, by connecting them like this, the midpoint lie here in this position. I will call it E. Okay, by looking to E, E is opposite to 5 and opposite to 3, then coordinates of E is 5 and 3. Because the 3 points E here, of course, at the midpoint, because the 3 points are collinear on the same straight line and they are vertical, then the x coordinate is constant. They are all opposite to 5 as we see. Okay, by looking here to x1, y1, x2, y2, and this is x and this is y. Okay, here we find x1 equal and x2 and x are equal, and 1 and 5 and 3. 1 plus 5 over 2 equal 3. This is the relation between y1, y2 and y. 1 plus 5 divided by 2 equal 3. Then this is the rule of y coordinates. y1 plus y2 over 2 equal y coordinate. Now I'm going to teach you how can I find the coordinate of a line segment, inclined line segment or sloped line segment, or in general. Okay, like this. If we back to the point A, which is 1 and 1, and connect between A and D like this, the coordinates of the midpoint lie in this point here, 3 and 3. Okay, here A 1 and 1, D 5 and 5, F 3 and 3. Okay, now to calculate the midpoint F in general of a line segment AD, okay, we make x1 plus x2 over 2, y1 plus y2 over 2 like this. x1 plus x2 over 2, y1 plus y2 over 2. And this is the rule you are going to study. x1 plus x2 over 2, y1 plus y2 over 2. This is the coordinates of the midpoint. By evaluate this one, 1 plus 5 over 2 equal 3, 1 plus 5 over 2 equal 3. Then the coordinates of F equal 3 and 3. Now let's solve some problems about the concept of the midpoint of a line segment. Now here we have example 1. Find the coordinates of the midpoint of AB. Number 1, A equal 3 and 5, B equal 7 and 1. Here we have, as we studied in the last lesson, x1, y1, x2, y2. Okay, then the midpoint equal x1 plus x2 over 2, 3 plus 7 over 2, comma, y1 plus y2 over 2, 5 plus 1 over 2, then 3 plus 7, 10 over 2, 5, 5 plus 1, 6 over 2, 3. Number 2, A equal 5, negative 3, x1, y1, x2, y2. Then the midpoint equal x1 plus x2 over 2, 5 plus negative 1. Next, I will not write positive negative because positive negative is negative. I will write minus 1 directly, okay, over 2, and negative 3 plus 3, or y1 plus y2 over 2. It will be 5 minus 1 equal 4 over 2, 2. Negative 3 plus 3, 0 over 2 equal 0. Then the coordinates of the midpoint is 2 and 0. Now what does it mean? if I draw A at 5, negative 3 and B at negative 1 and 3 and connect them as a line segment, we will find that the midpoint of this line segment is a point 2 and 0. So this rule is very important to find the coordinates of the midpoint. Now let's study how can we find the missing point. How come? Here the given is the start point and the end point, and the required is the midpoint. What if he give me missing points inside A and B? Let's study this one in the next example. Here in example 2, the point x and 0 is the midpoint of a line segment whose end points 1, negative 5, 2 and 5. Find x. First I'm going to draw the line segment like this, and here x and 0 is the midpoint of the two end points 1 and 5, 1, negative 5, 2 and 5. Okay, here x equal what? X equal x1 plus x2 over 2. So x equal 1 plus 2 over 2, which is equal 1.5. Okay, I don't need to check the other because the y coordinate exists in the 3 points, here, here and here. The next example. Example 3, if the point 5 and 3 is the midpoint of AB where its terminals, the word terminals means end points. Okay, R 5, 15y and B negative 5 and negative 2. Okay, this is the line segment. The end points A and B, and the midpoint is 5 and 3. Here 15 and y, here negative 5 and negative 2. Okay, y, okay, y plus y1 plus y2 equals 3. So y plus negative 2 over 2 equals the midpoint, which is 3. Okay, this is positive negative means negative. I will send 3 there as time. Then y minus 2 equals 6. I will send 2 there as plus. Then y equals 8. Then the point A is 15 and 8. The next example. Example 4. C is 6 and negative 4 is the midpoint of AB where A equal 5, negative 3. Find the coordinates of B. Okay, now I'm going to draw the line segment like this. Okay, here C is the midpoint of A B line segment. C equals 6 and negative 4. A equals 5 and negative 3. B is x and y. I call it x and y. So 5 plus x over 2 equals 6, and negative 3 plus y over 2 equals negative 4. Okay, I send 2 as time to be 5 plus x equals 2 times 6 equals 12. Send 5 to be minus, then x equals 12 minus 5, which is 7. This is x. Now I will send 2 multiplied by negative 4. It will be negative 3 plus y. 2 times negative 4 equals negative 8. Now I will send negative 3 as plus 3. Then y equals negative 8 plus 3 equals 5. Therefore, the point B equals 7 and 5. Excuse me, negative 8 plus 3 equals negative 5. Then it's 7 and negative 5. Example 5. If the point of the origin is the midpoint of the line segment AB, where A equal 5 and negative 2, find the coordinates of B. I will solve this one by two different methods. Okay, the first way is the way that we used to do in the previous examples, which is the equation. Okay, here by looking to this line segment, the point origin is 0, 0 is the midpoint of A, 5 and negative 2, B, x and y. So 5 plus x over 2 equal 0, and negative 2 plus y over 2 equals 0. Okay, send 2 there, multiply to be 5 plus x equal 2 times 0 equals 0. 5 go there as minus 5, then x equals negative 5. Okay, now I'm going to send 2 there, multiply, then negative 2 plus y equals 0, and then I'm send negative 2, it will be positive 2. Then B equals negative 5 and 2 by looking carefully to B and A. Again, B and A. B 5 and A 5 and negative 2, B negative 5 and positive 2. Then you can find B directly by changing the sign of A. If the origin is a midpoint of a line segment, then you just find the additive inverse of this point or change the sign of this point, okay, without solve or without using these steps. Okay, now I'm going to study some figures. We use the coordinates of the midpoints in these figures. Okay, this is important remarks. Okay, the first figure, if we have a triangle, and of course we studied the median, this line which is called the median of the triangle. What is the median of the triangle? The median of the triangle is a line segment connected between the vertex and the opposite midpoint. Okay, so if he gave me a median, then the median is a line connected between the vertex and the midpoint, so we use the midpoint, okay, if we have a median. Okay, the second shape is the circle. Okay, in the circle we use the midpoint. How come? If we have this line which called the diameter is a line segment connecting between 2 points and passing through the center. The center divide the diameter into 2 halves, so the center is the midpoint of the diameter. Okay, the third shape is the parallelogram. When I say parallelogram, the properties of parallelogram, okay, included inside the rectangle, the square, and the rhombus. So the property I will explain now included inside parallelogram, rectangle, square, and rhombus. Okay, we know before that this line is called a diagonal and this line is called a diagonal. The diagonals bisect each other. Bisect each other means that they are intersecting at the same midpoint. This point is a midpoint of the long diagonal and also the midpoint of the short diagonal, because the diagonals bisect each other. As I said before, this property included in the parallelogram, rectangle, and rhombus and square. Okay, now by using this concept, let's solve the figures by using the midpoint. In this example, example 6, if AD is a median of triangle ABC and M is a midpoint of AD where A equals 0, 8, B equal 3 and 2, C equal negative 3 and 6, D, the coordinates of D is what and the coordinates of M is what? Okay, first I'm going to draw the triangle like this and I will call it A, B, and C. He say that AD is a median, so I will connect from A to BC like this. This one is called D. D is the midpoint of BC. So to find D, I will find the midpoint of B and C. Then 3 plus negative 3 over 2 equals 0. And 2 plus 6 over 2 equals 4. Then D equals 0 and 4. Okay, now M is what? M is the midpoint of AD. Then M lie here in this place. Okay. Okay, as I said here, M is the midpoint of AD, then M like this. To find the M, I will find the midpoint of A and D. A equals 0, 8, D equals 0 and 4. So 0 plus 0 over 2 equals 0. And 8 plus 4 over 2 equals 6. It will be 0 and 6. The next example. AB is a diameter of circle M if B equal 8 and 11, M equal 5 and 7. Number 1, find the coordinates of A. Okay. Number 2, find the perimeter of the circle where pi equals 3.14. Now I need to draw the circle like this, and of course I need to draw its diameter like this. I will call it A, B, and M is the center of the circle, which lie in this position here. M of course is the midpoint of AB. So to find the coordinates of A, M equals 5 and 7. B equals 8 and 11. A equal X and Y. So X plus 8 over 2 equals 5 and Y plus 11 over 2 equals 7. Of course, this is number 1. I will send 2 multiplied by 5, then X plus 8 equal 10. Send 8 minus 8, then X equals 10 minus 8 equals 2. This is the coordinates of x. Y, 2 times 7 equals 14, then y plus 11 equals 14, then send 11 to be minus 11, then y equals 14 minus 11 equals 3. Okay, now a equals 2 and 3. This is required number 1. Number 2, find the perimeter. The perimeter of the circle means the circumference. And before we explained the circumference, which is 2 times pi times r. Okay, now I need to evaluate r. R equals square root. I will find r equal AB, AM or MB, or we can find AB and divide it by 2. Okay, I will find it by using M and B. Okay, then it will be 5 minus 8 power of 2 plus 7 minus 11 power of 2. It's equal 5 length units. Okay, now r equal 5 length units, then c equal 2 times 3.14, because he gives me 3.14 times 5. This is equal 2 times 3.14 times 5 equal 31.5. Excuse me, it's 0.4. length units. Now let's solve example 8. In this example, prove that the points A, B, and C are vertices of right angle triangle at B. Okay, this is the first required. Okay, now I will draw the triangle like this, and first I will find AB. AB equal 6 minus 2 all power of 2 and 0 plus 4, because minus minus is plus, equal 4 square root 2. And BC equals 2 plus 4. 2 minus minus 4 means 2 plus 4, and negative 4 minus 2 all power of 2, which is equal 6 square root 2. And AC equals 6 plus 4 all power of 2 and 0 minus 2 all power of 2 equals 2 root 26. Okay, now I will square the three sides like this. AB power of 2 means 4 square root 2 power of 2, which is equal 32. And BC power of 2 equals 6 root 2 all power of 2 equals 72. And AC power of 2, which is 2 root 26 power of 2 equals 104. Okay, Here the two smaller sides AB and 72, 32 plus 72 equals 104. So AB power of 2 plus BC power of 2 equal 104 power of 2. So the triangle is right. Okay. Therefore, or since AB power of 2 plus BC power of 2 equals AC power of 2, therefore angle what is right? By looking to the big one, AC, the missing letter is B, then angle B is right. This is the first required, and then I will write the coordinates. Here I will write B, A, and C. Okay. The second required, then find the coordinates of D. That makes the figure ABCD is a rectangle. Okay. To complete the rectangle, I will draw like this. And I will draw, this is of course the point D. Okay. And I will draw the other diagonal. Here D equal X and Y. Okay. Now, as we studied before, the diagonals of rectangle bisect each other and they are equal in length. Okay. Now, to find D, I can't find D directly. So I will find the midpoint of AC, and then from B and C I will find B. Here A equals 6 and 0, B equals 2 and negative 4, C equals negative 4 and 2. Okay. Now the midpoint of AC, I will call it M. M here equal 6 plus negative 4, or 6 minus 4 over 2, and 0 plus 2 over 2. It's equals 1 and 1. So M equals 1 and 1, like this. From B, M, and D, I can find the coordinates of D. Here, X, I will, okay, since M is the mid point of BD, therefore X plus 2 equals over 2 equals 1, and Y minus 4 over 2 equals 1. Okay. From the first equation, X plus 2 over 2 equal 1, I will send 2 there. 2 times 1 equal 2. Then X plus 2 equal 2. Then send 2 there as minus. Then X equal 2 minus 2, 0. This is X. And here I will send 2 multiplied by 1 equals 2. Then Y minus 4 equals 2. Send minus 4 there as plus 4. Then Y equals 2 plus 4 equals 6. Therefore, D equals 0 and 6. You can check you are right or wrong. 0 plus 2 over 2 equal 1. And 6 plus negative 4 over 2 equal also 1. And this is the point D. Let's solve the next one. Prove that the points A, B, and C are vertices of an obtuse angled triangle. Okay, now I will draw the triangle like this, and I will call it A, B, C. But first I need to solve or to prove that the triangle is an obtuse angle triangle. Okay, first I will start with AB. AB equal five minus 3 all power of 2 and 3 plus 2 all power of 2, which is equal root 29. Okay, BC equals 3 plus 2 all power of 2 and negative 2 plus 4 all power of 2, which is equal also root 29. Okay, AC 5 plus 2 all power of 2 and 3 plus 4 all power of 2, which is equal 7 square root 2. Okay, now I'm going to square the three sides as usual. Then AB power of 2 equals root 29 all power of 2 equals 29, and BC power of 2 equals root 29 power of 2 equal 29, and AC power of 2 equals 7 square root 2 all power of 2 equals 98. Here 29 plus 29 equals 58, and the 98 greater than 58, so this triangle is obtuse. Therefore, or since AC power of 2 greater than AB power of 2 plus BC power of 2, therefore angle what is obtuse? Angle B. Okay, now I will call the points like this: A, B, and C. Here point B, here point A, here point C. Okay, now I after the proof, okay, find at B, then find the coordinates of D that makes ABCD is a rhombus and find its area. Okay, to find the point D, then I will complete the rhombus like this and connect the other diagonal like this, and this point I will call it D. Okay, B equals 5 and 3, C equals 3 and negative 2, oh, this is A. B 3 negative 2, C negative 2 negative 4, and A is 5 and 3. Okay, now I need to find the midpoint of AC, which is called M. So M equal the midpoint of A and C, which is 5 plus negative 2, or 5 minus 2 over 2, and 3 plus negative 4, or 3 minus 4 over 2, which is equal 1.5 and negative 0.5. This is M. Okay, here 1.5 and negative 0.5. Okay, now to find the point D. Okay, then D, which is X and Y, okay, X plus 3 over 2 equal 1.5, since M is the mid point of BD, therefore X plus 3 over 2 equals 1.5, and Y minus 2 over 2 equals negative 0.5. Okay, I will send 2 times 1.5 equals 3, then X plus 3 equals 3. Okay, I will send 3 there as minus. 3 minus 3 equals 0, then X equals 0. Okay, and I will send 2 times negative 0.5 equals negative 1, then Y minus 2 equals negative 1, then I will send Y there, 2 there, then 2, Y equals negative 1 plus 2 equals 1. So D equals 0 and 1. Okay, now as we see here, ABCD is a rhombus. The rhombus, we have its 4 points. Okay, the area, to find the area of the rhombus, we need to do what? To find the area of the rhombus, we need to find the diagonals. The first diagonal AC is equal 7 root 2. So I need to find the area, the length of the diagonal BD. Okay, then the area equal half BD time AC. Okay. Okay, now as I said, I have AC, the diagonal AC. Now I need to find the diagonal BD. Okay. BD, which is equal here B 3 minus 0 all power of 2 and negative 2 minus 1, which is equal 3 square root 2. Therefore area of ABCD equals half times diagonal 1 times diagonal 2 equals half times 7 root 2 times 3 root 2 equals 21 area unit. Okay, the next example. In this example 10, A belongs to x axis and B belongs to y axis. C equal negative 4 and 2 is the midpoint of AB. Find the coordinates of A and B. It's easier to draw the shape like this. This is x axis and y axis. This is x and this is y. Okay, the point C, negative 4 and 2 exist in this negative 4 and 2 here in this position. Okay, so I will draw a line segment like this. Okay, C equals negative 4 and 2. A belong to x-axis, then A here, which is equal 0 and y, because any number, any point belong to y-axis is x coordinate is 0, and the point B which belongs to x-axis is 0 and excuse me, it's x and 0, not it's x and 0 because it belongs to x-axis. Now it's easy to find x and y like this. X plus 0 because 4 and negative 4 and 2 is a midpoint. Then x plus 0 over 2 equals negative 4, and 0 plus y over 2 equals 2. 2 multiplied by negative 4 equals negative 8. Then x plus 0 equal x equals negative 8. 0 plus y equal y, and 2 times 2, 4. Then x equal negative 8 and y equal 4. Therefore, A equals 0 and 4. B equals negative 8 and 0. Example 11. In this example, A, B, C, D, A, B, and C are vertices of isosceles triangle. Prove that they are isosceles vertices of isosceles triangle. Okay. First, by drawing the triangle like this. Okay, A, B, and C. So I need to find A, B, B, C, A, B, B, C, and AC. A, B, equal negative 3 minus 0 all power of 2, and excuse me, negative 3 minus 3, x1, negative 3, x2, 3, and 0 minus 4 power of 2, it's equal to root 13. And AC equal negative 3 minus 1 and 0 plus 6, which is equal also to root 13. BC equals 3 minus 1 all power of 2 and 4 plus 6, which is equal to root 26. Okay, now since AB equals AC not equal to BC, therefore triangle ABC is an isosceles triangle. Okay, this is the first required. The second required, find the length of the drawn line segment from A perpendicular to BC. To draw now I will draw a perpendicular from A to BC like this. I will call it AD. Okay, now I have in the distance lesson we have solved example like this by using the distance, okay, by using Pythagorean theorem, but now I'm going to explain it by different method. Okay, like this. Here D is a midpoint of BC. As we explained before many times, in the isosceles triangle, the axis of symmetry bisect the base. Okay, now D equal what? D equal midpoint of BC, which is equal 3 plus 1 over 2 and 4 plus negative 6 or minus 6 over 2, which is equal to and negative 1. Okay, now to find the area of triangle ABC, I need to find the length of AD. So I will find the length of AD like this. AD equals negative 3 minus 2 all power of 2 and 0 minus or plus 1 all power of 2, which is equal root 26. Now I can find the area of triangle ABC. Therefore, area of triangle ABC, which is half times base times height, equal half times BC equals 2 root 26 times AD, which is root 26. Root 26 equal 26 area unit. And this is the end of the video. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.